Hello everyone, this is Lens Technology. In our last episode, we introduced a new friend, the water cooled chiller. Today, let's take a deeper look at how we give this big guy a health check. In the previous issue, we discussed the principles of water cooled chillers. This means that the test lab for such chillers cannot simply calculate cooling capacity by measuring air enthalpy difference like an enthalpy difference chamber does. What is the core measurement principle of a water-cooled chiller test laboratory? Simply put, it directly measures the heat carried away by water. Think of the chiller as a cooling capacity mover. The chilled water is the cold parcel it delivers, while the cooling water is the hot parcel it unloads. The most direct way to know how much cooling the mover can provide is to weigh the cold parcel and the hot parcel and measure their temperature changes. Specifically in the lab, high-precision flow meters measure the flow rates of the chilled water and cooling water circuits. Meanwhile, platinum-resistant thermometers accurately measure the tiny temperature changes of the water as it passes through the chiller. Then, using the formula, flow rate multiply temperature difference multiply specific heat capacity of water, we can accurately calculate the chiller's cooling capacity and the heat it rejects. The entire calculation is based on the principle of heat balance and is highly accurate. Now that we've covered the principle, let's look at its structure. Like the enthalpy difference and heat balance chambers, the water-cooled chiller test lab has indoor and outdoor sides, but its most distinctive feature is that it has two highly independent constant temperature water systems. On the indoor side, instead of an air handling unit, you'll see a precision chilled water constant temperature system. This system acts like a temperature-controlled kettle, continuously supplying the chiller with return water at an extremely stable temperature, simulating the chilled water returning from the air conditioning terminals after absorbing heat. On the outdoor side, there is a cooling water constant temperature system, which supplies the chiller with cooling water at a constant temperature, simulating water coming from the cooling tower. Both water systems can control water temperatures to 2 decimal places, and flow control is equally precise. Only under such dual constant flow and constant temperature conditions, once the entire system reaches thermal equilibrium, water temperatures and flow rates stabilize, can the measured cooling capacity and energy efficiency ratio be truly reliable. From this, you can see why this lab differs from enthalpy difference and heat balance chambers. The water-cooled chiller test laboratory directly measures the liquid secondary refrigerant and the heat rejection medium, capturing the core of heat transfer. It has fewer error sources, can directly measure both cooling capacity and heat rejection, and the two sets of data can cross-validate each other. If the cooling capacity and the heat rejection do not match the chiller's power input, a problem in the measurement can be immediately identified. This self-checking capability is a notable advantage. Therefore, it is widely recognized as the most scientific and intuitive method for testing water-cooled chillers, the gold standard for energy efficiency testing of this type of equipment. It is used not only for product rating and arbitration testing, but also as the most trusted eyes and yardstick for engineers developing next-generation high-efficiency chillers. So now you should have a good understanding of commercial water-cooled chillers and the laboratories used to test them. That's all for this episode. If you are interested in any other equipment, feel free to let us know, and we'll explore it together. Finally, if you need to purchase water-cooled chiller test laboratory, or if you are interested in energy-saving technologies for test labs, please feel free to contact us. Don't forget to like, save, and follow us. See you in the next exciting episode.